Welcome! Today in our video tutorial, we will learn how to build the Highrise financial model. We will be pretending that we are investors. We're thinking about purchasing a high-rise building. We're trying to figure out at which interest rate is the net present value equal to 0. In other words, what is the internal rate of return of the investment opportunity? The business concepts we will learn during this tutorial is how to discount future cash flows, how to calculate the net present value, how to calculate the internal rate of return. We will be doing some what-if analysis along with some sensitivity analysis when more than one variable is changing. The Excel skills we will cover. We'll learn how to build a model and practice our model building skills. We'll learn some new financial functions such as the NPV function and the IRR function. We'll learn about formula auditing tools. We'll learn the goal seek tool, and we'll learn how to create two-way data tables in order to create our sensitivity analysis. Alright, let's get on with building the model. The scenario we have set up, we're thinking about purchasing a high-rise building. We will purchase it in year 0 for $3.5 million. The interest rate we're going to use in order to discount our cash flows is 8.5%. We think that we might be able to sell it for $4.5 million in year 10. However, we don't know the future selling price because it's 10 years away. There's uncertainty in the future. We hope that we'll be able to collect $350,000 a year in rent from tenants who are renting the building, and we anticipate that our operating and maintenance costs will be $35,000 a year. We also hope that the occupancy rate will be at 100% every year for the next 10 years. In this spreadsheet, everything is color-coded. Everything that is green, bold font is a hard-coded number. That means it's a number that's typed into the cell. It's not a formula. As you can see in the formula bar, it's straight numbers. There are no formulas. The yellow and orange cells are our output cells. That means there will be formulas driving into the yellow cells, and we will use those to perform our sensitivity analysis. So let's start by building the model. We've got our years in the first column, starting at year 0, and then all the way into the future in year 10. We'll go one column at a time from left to right. We'll start with our annual revenue. We'll start by putting an equal sign. We anticipate that every year the occupancy rate will be 100%. So we are going to reference this cell, and we're going to press F4 because we want to make it an absolute reference. What that means is if we copy and paste this formula all the way down the column, we don't want the cell reference to move. We want it to be fixed. We want it to be glued into the same place. Now we know that we want to multiply the occupancy rate by our annual rental revenue. So we're going to reference that cell as well. We'll press F4 again because as this formula propagates or gets copied down the column, we want this reference to stay fixed. We want it to stay in one place and not move. Once we've referenced both of these cells and we've pressed F4 to make the dollar sign show up and to make them into absolute reference, we can press the Enter key. In order to propagate or copy the formula down the column, we left-click once inside of the cell. We put our mouse over the bottom right-hand corner of the cell until it turns into a black cross, and we're going to drag and drop all the way down to the column. Now we should get consistent revenue in each year because we're making the assumption that the occupancy rate will always be 100% and the rent will always be $350,000. You can spot check each formula to make sure that the references are staying absolute by double clicking inside the cells and looking for the colored boxes. The next column is the operating and maintenance expenses. Again, in year 1, we'll start with an equal sign. We're going to reference the operating and maintenance expenses every year. Do we want this reference to move down the column or do we want it to stay still? We want it to stay still, so we'll press F4, then we'll press Enter, and again, put your mouse bottom right-hand corner over that little box so you get the black plus, and we'll drag and drop in order to propagate. We're making the assumption that this will be consistent every year, so you should get the same value every year. Next column, total cash flow. In order to keep it simple, we'll start in year 1. We'll simply take our annual revenue. Do we want this reference to move down as we move down the formula? Yes, we do. So we will not press F4. Then we will subtract our operating and maintenance costs. Again, do we want this to move down as our formula moves down? The answer is yes, so we do not press F4. Then we press enter. Then we can propagate, again by dragging and dropping, all the way down the column. Now we have our future cash flows for year 1 through 10 with the annual activities, with the exception of the 2 events where we are buying the building and selling the building. Let's plug those in next. Let's plug the initial cost of buying the building into year 0. Because we're going to be spending the money, we're going to press a negative sign first, then we're going to reference the the purchasing price of the building, the initial cost of the building. This should give us a negative cash flow in year 0. Because we're buying the building now, it's not happening in the future, we put it into year 0. 10 years from now, we're going to sell the building. So I'm going to go into this formula, I'm going to activate it by double clicking. I'm going to go to the end of the formula, and I'm going to press a plus sign. I'm going to add in the revenue we will earn from selling the building. So I'm adding in the selling price. Then I'm going to press enter. Now we have our present cash flow at year 0, plus we have all of our future cash flows calculating for the next 10 years. Now that we've calculated the future values of each cash flow, we need to take each year and bring it into the present value so that we can compare apples to apples instead of comparing future values to present values or future values in different years. For each year, we're going to calculate the discount factor. Again, we start in year 1 because year 0 doesn't have a discount factor. It's already in the present value. We'll start with an equal sign, open up the bracket. The discount factor for each year is going to be 1 plus the interest rate. And we want to press F4 on the interest rate because we don't want this reference moving down as we propagate the formula. Close the bracket, press Shift and 6, which will give you the little caret or the little hat. That is Excel symbolism for exponent. So when we put the caret, it's called a caret, we're saying to the exponent of, and in this case, we're always going to make it to the exponent of the year. And the year, we want that reference to propagate all the way, or we want the reference to move down as we propagate the formula down, so we do not want to press F4. We want that to be a relative reference. We'll press enter. Again, we'll propagate. Left click 1 time inside the cell, hover over the square on the bottom right-hand corner of the cell until you get that black plus sign, drag and drop all the way down to the end of the column. Now that we have our discount factors, we can take each future cash flow and divide it by the discount factor. And we don't use any F4s here because we want this reference to move down. We also want this reference to move down. When we propagate this formula, then we will press enter. Again, left click, grab the plus sign, drag and drop down. Now all of our future cash flows have been brought into present value using the discount factor. It makes a big difference in our building selling price. Our future cash flow of $4.8 million is now only $2.1 million since we've discounted it at an interest rate of 8.5%. We've got one more step. In order to calculate our net present value, we need to add in the event that happens in year 0, which is purchasing the building. And now, in order to find out the net present value of our project, we're going to calculate the sum of all of the discounted cash flows plus our year 0 cash flow. In order to calculate sum, I simply typed equals SUM, open the brackets, swipe down all of the inputs, close the bracket, and then press enter. Now I've calculated the net present value of our model. I'm calling it the long way because we built all the steps of creating the discount factors, dividing by the discount factors. We took all of our future cash flows, we brought them into present value, and then we're adding up the sum of the present values of all of the future cash flows. Great. So now that we know how to calculate the net present value, or NPV for short, the long way, let's do a shortcut. We're going to use a function in Excel. Since we haven't used this function before, we're going to use the function wizard to calculate it. In order to use the function wizard, I click on the f of x in the top of the screen. It brings me up the function wizard dialog box. If I don't know the name of the function, I can search for it by typing in keywords to the search box and then press go. There's over 400 functions in Excel, so it's kind of like Googling or searching the database of functions. I'm going to press go. I find the NPV function. I can double click on it or press OK. It's going to open up the function dialog box. Each function has different arguments. Required arguments are bold. Arguments that are not required are not bold. So if it's not bold, it means it's optional. This function has two required arguments. One is the rate of discount over the length of one period. So that's the interest rate. We know that we used the 8.5 interest rate when we calculated our discount factor. We're also going to use that 8.5% interest rate in the NPV function. The second argument are all of the values. These are the payments and income. So we're going to swipe all of the future values. Basically, everything that happens in the future that we want to bring into the present value at the 8.5% interest rate is what we're going to swipe. Then we're going to press OK. There's one more step here. The NPV function calculated the present value of all of our future cash flows and added them all up at an 8.5% discount factor. We're going to double click in here again to activate it. At the end of the formula, I'm going to add in this negative cash flow that happens in year 0, which is the purchase price or the initial cost of the building. You can either press plus and add the negative value, or you can press minus and add the positive value. It doesn't matter as long as you're somehow subtracting the initial cost from the net present value. Now you should see that we have two different results, even that we should have two numbers that match, even though we calculated it two different ways. The final result should be the same. Great. So now we have our net present value calculated. We've done it one way using the NPV function. We've done it another way using the discount factor, discounting the cash flows, and adding them all up. You should get two results that match after doing it two different ways. Now we're ready to do some sensitivity analysis on the model. Since the model is all live, which means that all of these green cells have been referenced and plugged into the data or plugged into the model, they're all flowing through the model. We can take a look at how the model flows by going to the Formulas tab. If I click on an output cell, which is either of my yellow cells, and I click on Trace Precedence, it's going to show me the structure of how all of the inputs flow into the output. And as you can see, there's blue dots on every single input, which means that they are all impacting the output. That means if I change any of these green font numbers, my net present value is going to change because it's all linked, it's all connected, it's all live. I can go up here and click Remove Arrows. I can click on my other output cell, and again I can see the same thing. I can see the pattern of the arrows, and I can see how everything is connected. I can see how the data flows through the model. I can do the same thing with an input cell. If I go to my interest rate and I click on Trace Dependence, again I can see everything that gets impacted by the interest rate. I can remove the arrows and go to the selling price. Again, I can look at everything that's impacted by the selling price. So since we know now that the green cells the green font cells all flow into the model, we can change one of the cells and it's going to impact our net present value. And we can look at the impact that it has on the net present value. For example, the occupancy rate, we assumed it would be 100%. Let's try changing it to 90% and see what happens to our net present value. It goes down. It's still above 0, which means it's still a good investment. It's still positive, but it goes down a little bit. What if the occupancy rate goes to 80%? Our net present value goes down even more. What if it drops all the way to 70%? Oh no, now we're losing money. It's negative. And if I drop the occupancy rate all the way down to 35%, we're losing a ton of money. So now you can see how the occupancy rate changing impacts the net present value of the building. And since it drops below 0, it impacts whether or not this investment is a good decision. Let's try another one. Let's try changing the selling price. Instead of $4.5 million, let's change it to $4 million and see what happens. The net present value goes down. It's still above 0, but it goes down a little bit. What if we drop it to $3.5 million so that it's equal to the selling or to the initial cost? It still goes down. It's not negative yet, but it's down lower. Let's put it down to $3 million. Now we're into the negative net present value. But it's highly unlikely that we're going to sell the building for $500,000 less than the amount that we paid to purchase it. So let's put this back up to $4.5 million again. And let's use the Goal Seek tool to do some sensitivity analysis. The Goal Seek tool is in the Data tab under What If Analysis. You're going to choose Goal Seek from the menu. And what the inputs that you need to put in this dialog box, anything that has a red arrow is going to be a reference. Anything without a red arrow is going to be hard-coded data. So the set cell value has to be a formula. If there's nothing flowing into it, Goal Seek won't understand how to calculate it. So we're going to set our net present value to 0 by changing the occupancy rate. We're going to do this to find the tipping point. We want to know exactly what occupancy rate is going to cause the net present value to become negative. We're going to press OK. Our net present value is now 0, and our occupancy rate is 75%. So that means that any occupancy rate below 75% is going to make our net present value negative. Any occupancy rate above this number is going to make our net present value positive. So this is the lowest occupancy rate we can sustain before our net present value dips below 0. I'm going to press Ctrl-Z to reset the numbers. I'm going to run Goal Seek a second time. This time I'm going to set the net present value to 0 by changing the selling price. I want to find out how much tolerance I have for the selling price to drop before my net present value becomes negative. Again, we have a net present value equal to 0. And look, my selling price went all the way down to $3.2 million, which is less than what I paid to purchase the building. That means there's a high tolerance for uncertainty with the selling price. There's a high amount of fluctuation that can happen before I'm losing money. Again, I'm going to press Ctrl-Z to reset these numbers. I'm going to do one more. This time, I want to find out what interest rate is going to make the net present value equal to 0. So I'm going to set my net present value to 0, and you can reference either one of these cells because they're constructed using the same inputs and the data flows the same way into both of them. It doesn't matter. They're always going to change and be equal. This time I'm going to change the interest rate. I'm going to click on OK, and now I see the net present value is 0 at an interest rate of 10.73%. That means that if I use a number higher or lower than this number to discount the cash flows is going to impact whether my net present value is below or above 0. Okay, so remember that this is higher than the 8.5% that we chose. Any alternative investment that gives a higher return of 10.73% is going to be a better investment than this building. Any alternative investment that has an interest rate lower than this will be worse than this building. So if we're comparing whether we want to invest in this building or another investment, this is the number that we want to use when comparing it to alternative investments. This is also the internal rate of return of the investment. The interest rate that makes the net present value equal to 0 is the internal rate of return. I'm going to press Ctrl Z to reset the numbers, and we're also going to calculate the internal rate of return of the project using a financial function. Again, I'm going to open up the function wizard. I'm going to type internal rate of return into the search box. I'm going to press go. Once I find the IRR function, I'm going to use the function wizard. There's only one required argument here, which is an array of cells that contain the numbers for which you want to calculate the internal rate of return. I'm going to swipe on all of the numbers and I'm going to press OK. It gives me the internal rate of return of all the cash flows, which is 10.73%, which is the same number that we found using GoalSeek. So again, we found the same result using two different methods. This is just an Excel financial function that might be useful. Now that we've calculated the internal rate of return and the net present value, and we've done some sensitivity analysis, we're going to create a two-way data table. We've set up a blank data table down below. What the data table is going to do is it's going to take multiple values at the same time, change them, and report the output. So we've got our inputs, which are the green font cells, and we've got our outputs, which are the yellow cells. Any output can be used for a data table. We'll start by using the net present value. You can also create a data table for the internal rate of return if you like. The first step in creating the data table is to put the output in the top left-hand corner of the table. We want to make sure that this cell is connected to our model, so it must be a cell reference. We're going to press equals. We can select any one of these three outputs. I'm going to select the net present value. Then we're going to press enter. Now we want to choose two inputs that are going to be changing in our table. I'm going to start with the occupancy rate and the selling price. I know that the occupancy rate is 100% as our assumption, but it might drop. It might drop to 80%, it might drop to 70%, it might drop to 60%. So I'm going to choose 50% as my first occupancy rate. Then I'm going to fill in all of these cells. A shortcut to fill is to go to the Home tab, Fill Series. I want to fill it across the row, so I'm going to select Row. I want it to increase linear. I want my step value to be 0.1, so in increments of 10%, and I want it to stop once it gets to 100%. 100% is the same as 1. I'm going to click on OK. I've got my percentages filled in across the top. Now I'm going to fill in my selling prices across the bottom. Let's start with the selling price of $3.5 million because that's how much we paid to buy the building. Again, we're going to go Fill Series. This time we want it to go down the column, so we'll choose column. We want it to go up in increments of, let's choose $50,000, and we want it to stop at $5 million. And we'll press OK. That's OK. So we've got a nice big table with lots of different options. So now what we will do, we've got different occupancy rates across the top. We've got different selling prices across the left. In order to put the table together, we need to know what our row input is, we need to know what our column input is, and we need to know that we're going to go to the what if analysis, which is in the data tab. So I'm going to select the entire table. You can use your Control Shift down arrow, Control Shift right arrow combinations to easily select the entire table. I'm going to go to the data tab. Under what if analysis, which is the same place we went for goal seek, I'm going to choose data table. It's going to ask me two questions. What is the original input cell in the model that flows into our output cell that's on the row? The row has the occupancy rate. Our original input cell is here. This cell inputs into here, which is connected to here. So it all flows through the table. What is the column input cell? Selling price. So we're going to go find the selling price as our input and then click on OK. It's going to build a table for us. Let's clean up the formatting a little bit. I'm going to left click on this cell, take my left hand, hold down Control and Shift together, tap on the right arrow, tap on the down arrow. I'm going to go to the Home tab, throw some commas in there, and I'm going to clean up the decimals. Now we've got some negative numbers and some positive numbers. I'm going to use conditional formatting to easily see which ones are negative and positive. I'm going to go highlight cells rules. If it's greater than 0, it's going to be green. If it's less than 0, it's going to be red. Now I can clearly see when my net present value is positive and when my net present value is negative. And I can see at what selling prices are we having more risk and what selling prices are good. If it's $5 million, it's great. Also occupancy rate, if it's 90%, it's pretty good. As soon as we're getting down to 80%, it's not that good. So what Excel is doing when it builds the data table is it's taking different combinations of input and it's changing these values here and it's reporting the output. So for example, we can see that at 50% occupancy rate, we've got negative 1 million NPV. So I'm going to take this 50% and plug it in here. It's changing the occupancy rate to 50%. It's changing the selling price to 3.5 million. Our NPV is negative 1 million. This number is the same as this number here. If I change this to 60%, but I keep this selling price, the combination of these two inputs is going to create this output. So I've got 3.5 million as my selling price, but if I change the occupancy rate to 60%, my NPV is negative 800,000. This number is the same as here. This number is always going to equal these yellow cells because it's live. It's linked. And if I go to my Formula tab and trace the precedence, you can see how it's all connected. And if I go to the table, it's not going to work. If I go to the table, you can see that this cell is connected to here and it's all connected to our inputs. You can also see that in the formula bar, the table function has curly brackets around it. Curly brackets means it's an array function, which means it's a function that applies to a range of cells. It applies to more than one cell at the same time. And these two references, E4 and C4, those are the inputs that you plugged into that dialog box when it came up. Let's do one more. Let's put our occupancy rate at 100%. And let's put our selling price all the way up to 5 million, just so that we can see what's happening. Now our net present value is 778,252. And if we go to the bottom right-hand corner of the table, you can see that that combination of selling price and occupancy rate is 778,252. One more thing you can do with these data tables is you can change the input cells on the row and the column. So if I want to change it, instead of 50, 60, 70, if I want to go 55, all the numbers in this column are going to change. If I want to go 65, that column will change. 75. Whoops. 75. 85. 95. So you can change those, and then I can just go 99. So you can change all of your inputs. I can also change these numbers if I want to. If I want to completely change the pattern, I can go 3.5 million, then I can go 4 million, 2, 3, 4, 5, 6. I can take these numbers, propagate them all the way down. What if the building sells for $18 million? Maybe I want to get really rich. Oh, look at all the green. So we can change the numbers in the input on the row and the column of the table. So that wraps up the Highrise lab. There's a lot of skills packed in. Again, just to recap, we've learned how to discount future cash flows 2 ways. We use the discount factor and we use the net present value function. We learned about the net present value, which is the sum of the present values of all of the future cash flows. We calculated the internal rate of return, which is the rate of return that makes the net present value equal to 0. Can also be calculated using the IRR function in Excel. We did some what if analysis. We went to the data tab. We went what if, and we did goal seek. We also created a two-way data table. We did some sensitivity analysis, which means we changed the inputs and we watched how they impacted the outputs. So how sensitive is the output to a change in the inputs? We practiced our model building skills in Excel, which means we practiced cell referencing, we practiced absolute values, relative values, formula propagation. We learned some financial functions. We learned the NPV and the IRR function using the function wizard. We learned the formula auditing tool, which again is in the formula tab, trace precedence and dependence, which gives us the blue arrows and maps out the patterns of the formulas and cell references. And we learned goal seek, which again is in the data tab, what if analysis, goal seek. And we built a two-way data table, which again is in the what if analysis section of the data tab. So hopefully that video is helpful. Hopefully answers any questions that you have. And again, I highly recommend watching the video with the Excel spreadsheet in front of you so you can work through the model at the same time. That's all for now. Have a wonderful day.